Hello everyone, today I'll be covering differentiation. The derivative is the slope of a function. More specifically, given this graph of x squared, is the slope of a line tangent to that function. To notate the derivative, we can use f prime of x, dy over dx, or d over dx. If you want to find the derivative of a function algebraically, you can use the limit definition. Here's the general limit definition when you want to find the slope of the entire function, and if you want to find the slope at a certain x value, you can use this. You can differentiate only when your function is smooth with no sharp corners. So for example, at x equals 0 in an absolute value function, you cannot differentiate. But in a parabola, since it's smooth, you can. Additionally, your function must be continuous at that x value, which I covered in my previous video. Since there's a hole and therefore it's not continuous, you cannot differentiate at x equals 0. But again, you can in this smooth parabola that was continuous. Now, the limit definition can get quite cumbersome to use, so you can use the power rule to make differentiation a lot faster. However, n must be a real number and not a variable. The product rule can be used when you have a function that multiplies two functions together. So here's what it looks like. There's a pretty cool proof you can look up online. Now, here's an example. Since x squared and sine x are two functions that are multiplied together, you can use the product rule. Now the derivative of x squared is 2x, and you just keep sine x the same, and then you add x squared. You don't take the derivative of that, but you do take the derivative of sine x, which is cos x. Now the quotient rule works pretty similarly, but it's also a little bit different, and you just use it when you're dividing two functions. Here's an example of using the quotient rule to find the derivative. Thank you guys for watching.